A very good morning to Doctor and all my friends. Today, my proposal topic is synthesis and characterization of dimethyl phthalate based in printed polymers via electropolymerization. My supervisor is Dr. Mo. Background study. Dimethyl phthalate is widely used as the fertilizer, insecticide, pesticide, and other applications. However, it causes the pollution towards the environment and also bad implication to the human health. Therefore, we have some sensing method to towards the dimethyl phthalate. We have the HPLC, GC, and also MS, but it is pricey and also consume time. Therefore, we have the MIP sensing method because it has a higher selectivity and also sensitivity, just like the enzyme substrate complex. Problem statement: the detection of the DMP in all environment metrics can be conducted by using the EMIP sensor. So the EMIP sensor is easily going everywhere in all environment metrics because it can detect like soil, sediment, like that. Objective: the first objective is to determine the capability of EMIP to absorb the DMP and characterization of EMIP and other material used to generate a quicker, more stable, sensitive, and cost-effective ARP sensor that can be exhibit the excellent identification capability and sensitivity. Literature review. These are four uses of the phthalate, which are pesticide, plasticizer, moisturizer, and solvent. Four uses are common in our market. Implication of dimethyl phthalate towards the human health and environment. We have four. First of all, we have blood immunogenicity and also the interference in the reproductive system and the endocrine system in our human body, endocrine system disruption of zebrafish, and also the genotoxic and physiotoxic effect in dark red blood. EMIP sensor optimization, ratio of DMP to pyro. This one is the one of the optimization. The peak current difference in the cyclic photometry is one of the parameters to detect the best optimized ratio of them. The overabundance of the monomers in the EMIP layer will cause reduce in peak current, and because will influence with the DMP detection and also the chemical removal process. The low monomer concentration will cause the low number of cavity which is formed. Therefore, our redox probe, which is the potassium ferrocyanide, cannot enter to the cavity. Therefore, they cannot be detected by the electrode. So we have the lower current difference. Electropolymerization cycle number. We need to maintain the thickness neither too thick nor too thin. So the peak current difference also the parameter to detect the best optimized cycle number. If we have thin EMIP, will cause the unstable cavity, and for the thick EMIP will cause the fewer accessible printing spot. Next with the electropolymerization rate. The lower rate will decrease the number of the cavity EMIP. The faster rate will cause the orientation of the cavity printed on the EMIP film is changed. The template removal cycle will use the overlay station. Therefore, you have a lot of the functional group inside the EMIP surface to remove the template and as well. Cyclic photometry will determine the overall station cycle number. Analytical instrument for characterization of EMIP. We have SPM to check the morphological and also chemical structure of the base electrode or the electrode which is modified like that. The FTIR is to check the interaction between the functional monomer and the template molecule complex, MIP, NIP, like that. We can check the functional group. The X-ray diffraction is to check the degree of crystallinity, the EMI, of the MIP and also the NIP. Analytical instrument for electrochemical characterization of EMIP. We use the redox probe, which is the potassium ferrocyanide in our cyclic photometry, is to check the electrochemical performance of the base electrode and also the modified electrode, which is polypyro is the and also EIS we use the check the electrode whether the alteration of the capacitance and also resistance RCT value like that. Methodology. This is the listed down the chemicals and materials. Next we have the apparatus, It's the multi-wall carbon nanotube preparation. This nanotube is to enhance the conductivity of the electrode. So we have used the 1 gram of MWCNT after we going to weigh, submerge, wash, and after that we get the suspension. Next, the PGE and MWCNT electrode. PGE is the pencil graphite electrode. So the nanotube is deposited pencil graphite electrode using this procedure. After that, same thing, MIP is deposited on the electrode layer and also the NIP on the electrode layer. So we use the pencil graphite electrode, AGCl, and the PP electrode. The pencil graphite electrode is act as the working electrode, and also the PP electrode is used as the counter electrode. AGCl is the reference electrode. After we're going down the process, then we get the MIP and non-impeded polymer. They will get deposited on the modified electrode. So this is the sum analysis. The SEM analysis, we need to have the lightweight, and also FBIR, we need to have the 500 and 4000 cm minus 1. XRD, same thing, and also CV analysis. Come to the EIF, we need to set up the range to detect the potential using the 0.2 volt like that. So the expected result, we will optimize the ratio of the polypyrrole and also DMP using the techniques and also the creation of cavity, the binding and removal of template before and after like that. So this is the flow chart and also this is the proposed timeline. So now reference the depth. Thank you.